got another problem up on the board for us. 3 cosine of x plus 1 equals 0. I'm going to approach this the same way. I want to isolate the trig function, so I have just trig function equals a number. So I'm going to subtract 1. So I'll have 3 cosine x equals -1. I'll divide both sides by 3. So cosine of x is -1/3. Okay. All right. Now, might feel a little uneasy because that's not one of the values that I recognize from my quote-unquote nice angles, pi over 6, pi over 4, and pi over 3. We'll get there, but I still need to know what quadrants I'm in. So let's start with that. Cosine would be positive in quadrant 1, so no solutions there. It's negative in quadrant 2, so I'm going to have a solution in quadrant 2. Now, in quadrant 3, cosine is negative, so I'm going to have a solution there. But in quadrant 4, cosine would be positive, so no solution there. So once again, I just need to know alpha, my reference angle. But I can see I'm not going to get one of my nice angles, 30, 60, or 45 in degrees, which would be pi over 6, pi over 3, and pi over 4 in radians, because I can see none of these triangles has a side, this is a horrible 45, 45, 90, but none of these has a side of just 3. There's a root 3, but there's no 3 outside of the root. So, what I know about alpha is that cosine of alpha is the absolute value of -1/3, which would be 1/3. But I also know that alpha is an acute angle because the reference angle is always a positive acute angle. So alpha is the acute angle whose cosine is 1/3. I know what that angle is. It's arc cosine of 1/3. So I'm going to have to describe it using inverse trig, but I can do that. So I want to be able to recognize when I get an angle that I can describe without inverse trig, I should do that. So when I had 45 degrees, which was pi over 4 in the last example, I didn't leave that as arc sine of root 2 over 2. If it's nice like that, I should be able to evaluate that. But if I'm not going to get pi over 6, pi over 4, or pi over 3, I'm going to describe the reference angle in terms of inverse trig. So here, I would say x is pi minus alpha. So that's just pi minus arc cosine of 1/3. And here, x is pi plus alpha. So that's just pi plus arc cosine of 1/3. Those are my two solutions between 0 and 2 pi. Okay. Now, I ended up taking the absolute value here because that way I was able to get the reference angle because I needed the reference angle in both quadrants. In this case, this angle x is actually just arc cosine of -1/3. So that would be another way that I could write, let's see, this one. I could have just written arc cosine of -1/3. So sometimes, depending on which trig function is involved, and depending on what quadrants you're in, you might be able to describe one of your solutions using an inverse trig function applied to a negative value. Gotta remember, with inverse sine and inverse tangent, if you're taking those of a negative number, you get an angle in quadrant 4 that's a negative acute angle. So that's never going to give you something between 0 and 2 pi. Okay. But I could work with that negative angle if I wanted to. I think it's simplest to always just find the reference angle because you're going to use the reference angle, the same reference angle, in describing all of your solutions. And what's nice is the reference angle, because it's an acute angle, it's in the range of every inverse trig function. So I don't have to think, does this inverse trig function give me an angle in that quadrant? Because the reference angle is always an angle that if I drew it in standard position would be in quadrant 1. So I'm always going to do things this way. So my answers are going to be in the interval from 0 to 2 pi. I'm getting these two things, pi minus arc cosine of 1/3 and pi plus arc cosine of 1/3. Now, as you're doing the homework, it's possible that the answers in the back of the book will look a little bit different. They might have chosen to describe that as arc cosine of negative 1/3. And then this one can also be described in terms of arc cosine of negative 1/3, but it's a little trickier because that's this obtuse angle rather than being the reference angle. So, if your answer isn't an exact match for what's in the back of the book, there are a couple of things you can do. One is you can use a calculator to plug in your answer and plug in the book's answer. If you get the same decimal approximation, they were probably just equivalent ways of describing the same angle. Two, you can look at those angles and see if you can figure out why they're actually the same. Three, you're welcome to ask me. But I just want to give you a heads up that you might do these problems correctly and your answer doesn't match the way it's given in the back of the book. Doesn't necessarily mean you've done things wrong. I think the simplest thing to start with would be to simply take out a calculator, make sure you're in the appropriate radian or degree mode, plug in your answer, plug in the book's answer. If you get the same decimal approximation, they're probably just equivalent ways of describing the same thing. Okay. All right, now if I wanted all solutions, it's the same basic thing. I'm just going to add a multiple of 2 pi to each of these. So I'm going to get pi minus arc cosine of 1/3 plus 2 pi n, and then I'm going to get pi plus arc cosine of 1/3 plus 2 pi n, in both cases where n is an integer. Okay, so I'm going to put up another problem on the board for you folks to try. We'll end this video here, but before you turn on the next video, try this one on your own, and then we'll work through it together in the next video. Okay. So let's say 4 sine of x minus 3 is equal to 0. Okay. So give that one a shot. We'll take a look at it together in the next video.